Okay, here we go with the quotient rule. I don't have the formula memorized as much as I have my loop memorized, right? F prime, G prime, and then with the negative, right? And then I like also over here put the over G squared. I want to think about this as over G squared. And you might ask why, and I'll say to you, oh, you'll see me do the proof of the product rule, and then the proof of the quotient rule is very similar. But let's do a couple of examples first. Yeah, question? Yeah, it's okay that you're writing it over. You had it on your other page, right? I just wrote it again just so as a reminder what we're talking about here. Okay, no problem. So this is number 5 in the book. I've got y equals e to the x over x squared. So our upstairs function is e to the x. What's the derivative? Good. The downstairs function is x squared. What's the derivative? Good. And the downstairs function squared is x squared squared, or x to the 4th. So y prime, is that okay? Everybody there? Y prime, I'm taking this one first, right? Is x squared e to the x minus 2x times e to the x all over x to the 4th. That's simple. You just got to stay organized, and you have to practice, right? At this point, we're assuming you can do all of these shortcuts as well, right? So notice I can factor out an x e to the x. And then one of my x's will cancel. Let's double check on Desmos that we have this right. So my original function was y equals e to the x over x squared. Funky little thing. And I want to take the derivative of that with d divided by dx. D, the top D, means what? What's that top D mean in the numerator? Derivative. What's the dx mean? X is the variable, independent variable. So you're taking, say again? The derivative with respect to x is kind of what it says. D dx says take the derivative of this with respect to the function x. So there is my derivative. And look at the function, the derivative we actually got was e to the x times x minus 2. Is that correct? X minus 2? all divided by x cubed, correct? And you can see did I miss a 2? What 2? Oh. And so, but you can see that, right? It's the exact same function. Yes? This is easy, right? It's pretty easy. Am I right or no? All right, let's do f of x equals x over x plus 1. I think you might remember this function from section 2.1. Yeah, sure. There? Because the numerator has got only a shared factor of x in it. Yep. Ask any question you got. I don't care. And the worry is if you ask a question and then still don't understand it. That's after I answered it. But then you got to tell me and give me another chance. So say it a different way. But when you ask stuff and it's clear to you, that's great. Those are important thoughts that you just want cleaned up in your own head, right? Let's do this one. Sorry. So quotient rule right away, right? Yes? So my upstairs function is x. The derivative of that is 1. The downstairs function is x plus 1. The derivative of that is 1. And I also, of course, need the downstairs squared, which is just x plus 1 quantity squared. And no, don't FOIL it out. Keep things factored. So y prime is, right, this one first, x plus 1 minus x over x plus 1 quantity squared. So it looks like I just get 1 over x plus 1 quantity squared. Let's do a tangent line there. So someone give me an x value to pick. 1 is fine. So then what's y? 1 over 2. And what's m? Yeah, 1 over 4. Nice. Our tangent line is y minus what? Don't copy me, erase me. You remember doing this one with the limit? You remember this one in 2.1? 1 and 1/2. We got the same tangent line when we did it that way. All right, so we're checking ourselves on Desmos. Y equals x divided by x plus 1. I had the point 1, 1/2. Nice. And I have the tangent line y equals 1/4 x plus 1/4. Oh yeah. So product rule, quotient rule, right? Do lots of them. I like all of the problems from 1 to probably 45. 3.2. Yeah, it's 3.3. I click on 3.3 and then go backward to get to the questions on 3.2. We want to be able to do second derivatives as well, okay? So I'll just talk about that real quick. A first derivative tells me that the function is either increasing or decreasing. The second derivative tells me about concavity. Concave down, it's like this, like a dome. Concave up, like a smile or a bowl, okay? So we would like to look at a second derivative, if possible. So let me actually look at. Let me take something simple. Let's do this one again. Let's do e over square root, e to the x over square root of x. And so let's find the second derivative, right? So find y double prime, the second derivative. Yes, you with me? So what do? I just find the first derivative and then treat that like its own function and then find the second derivative, right? So first derivative, upstairs function, e to the x. What's the derivative of that? E to the x. Downstairs function, square root of x. And the derivative of that, 1 over 2 square roots of x, right? 2 square roots of x in my denominator. And of course, the downstairs squared is just x. So y prime is square root of x e to the x minus e to the x over 2 square roots of x, all divided by x. I want this thing completely factored before I move on, right? So it looks like I need an LCD here of 2 rad x over itself. And then I can factor out an e to the x. Same as before, right? Yeah. I did a keep change flip. I factored and I did a keep change flip. You'll often see this as in the book even x 2x to the 3 halves, right? 2 halves power, 1 half power, but I like this one better. Oh, I picked such a nasty one to do the second derivative for, because inside of the numerator is a product and inside the denominator is a product. I save a little work by using this version. So upstairs function is e to the x times 2x minus 1. But I need a product rule there to get my derivative, right? So I'm going e to the x, 2x minus 1, 2. And I'm doing a product rule there. So that's 2 e to the x plus 2x minus 1 e to the x. I know I did that kind of quick, but you're all not writing, so I don't care. Yeah, so are we okay with the first derivative? Ethan, what'd you say? Yeah, keep change flip. So 1 over 2 square roots of x divided by x is 1. Keep change flip. Yep, it's okay. Downstairs function is 2x to the 3 halves. Derivative is 2 times 3 halves times x to the 3 halves minus 1. So that is 3 square roots of x. Nice. Woo! Horrible. And the downstairs squared is x squared. You can see how nasty it becomes if you have products within products, right? Or products within quotients. And it does get pretty nasty. You just got to be organized. Take your time. So y double prime is 2x to the 3 halves times all of this junk. Yeah? Yeah, where? Yes, don't. Where are you? For second derivative, if I have a product, I need a product rule. Right? So I have, you can see my upstairs function here is a product, yes? So I need the product rule for that. Yes, but inside of the quotient rule, I had a product. In my numerator, I had a product. So I had to do the product for that. Right now, I'm doing the quotient rule, right? I get this right here, quotient rule. So minus 3 square roots of x e to the x times 2x minus 1 all over x squared. Ugh. Pretty friggin' hideous. So it's definitely not what's in the book. So I have to simplify as much as I can. I'm kind of working in here first, right? And it's hard to see, but I can take out a square root of x and an e to the x. Whew. Oh, hideous, right? The algebra. Not easy. Doesn't mean you can't do it. Let me prove to you the product rule. Yeah, question. Yeah, so it's probably easier for me to do it, to talk about it with a nice simple function. So let's take a look at the first derivative and the second derivative and what it says about the graph. So, for example, y equals x minus x cubed. Okay, so there's my function, right? I can get the derivative really quickly here, right? What's my derivative? 1 minus what? 3x squared, right? 3x squared. Now notice where the function is decreasing, right? All the way here. The derivative is underground. The derivative is negative. So when the derivative is negative, the function is decreasing. When the function is increasing from here to here, yes, the derivative is positive above that. And where the function is decreasing again, the derivative is underground negative. Negative derivative means decreasing function. Positive derivative means increasing function. Second derivative. What is it? Six x, right? This talks about concavity of the original function. The original function is smiling. Smiling people are positive people. So the second derivative is positive. This is my x-y negative. Yes? Rounded. Negative. Underground. The second derivative is underground. Yes? Do you know the word? I just take the derivative of the first derivative. Oh. Yeah. Okay. So derivative of 1, 0, derivative of -6. Yes. Chapter 4. Yes, it's going to ask you right away a lot of times, find the second derivative, because you're going to need it. In fact, in Calc 2, we do a fourth derivative. All right, let me prove the product rule. You don't have to write it. Okay? You can easily find it some nerd on the web doing it. You could find someone doing the quotient rule, of course, right? YouTube, Calc 1, proof of product rule. Don't write it. I want to show that y equals f of x times g of x implies that y prime is what? Do you remember it already? Look at my loop. Pretty easy if you look at the loop. Yeah, f of x times g prime of x, sorry. Yep. Plus g of x times f prime of x. Well, guess what? I need a limit as what? As h goes to 0 of f of x plus h times g of x plus h plus f of x, sorry, minus f of x times g of x, right? All over h. Yuck. So the trick here is to add nothing. We multiply by 1, that does us nothing. If we add 0, we do nothing as well. So we're going to multiply this, we're going to add 0 to it, sorry. So f of x plus h times g of x plus h minus plus, and then f of x minus f of x g of x all over h. So I'm going to add nothing in the form of, don't tell me, f of x g of x plus h. So notice I subtracted and added the same thing. So I added 0, right? And now I'm going to divide and conquer. So take the first two terms over h plus the second two terms over h. Divide and conquer. When you divide and conquer, you just have to decide what terms are you grouping together and which ones are you not. What can I factor from the first one? G of x plus h, yeah. So I've got an f of x plus h minus f of x over h times the g of x plus h. And then the second one I can factor out an f of x. What's going to happen to this guy as h goes to 0? What happens to g of x plus h as h goes to 0? It just becomes g of x, right? H is gone, right? And what happens to this one? What happens to this one? Goes to g prime, right? Do you see g of x plus h minus g of x all over h? That's my derivative. And this one goes to f prime, right? So I got it. I got f, sorry, right? Starting here. I've got f of x times g prime plus g of x times f prime. Once I do my limits, I skip that, but you're not writing it anyway. Nice, most famous quotient rule of all, the tangent. So y is tangent of x. Who's got the derivative memorized? that's what tangent is. But what's the derivative? Anybody know it? Secant squared x. So y is tangent of x is the same as sine of x over cos of x. You should be writing so we're going to use a quotient rule. Ready? Yes, everybody ready? Upstairs function is sine of x, right? What's the derivative? Cos of x, nice. Downstairs function is cos of x. Derivative, negative sine of x. And then, of course, I have to be thinking of the downstairs squared cos squared of x. I'm using my quotient rule. So my first piece that I get is a cos squared. Do you see it? So I get a cos squared of x minus a negative sine squared of x. Yeah, that's an identity you better know. Upstairs, what is that? One. Let's do a tangent line. What x value? Pi over 3, sure. Sure. So I got an x value, I've got a function, I've got a derivative, I need a y value, and I need a slope, right? Everybody with me there? So what's my y value? Tangent of pi over 3, right? Which is? Just square root of 3. I need a slope. That's going to be secant squared of pi over 3. I don't know about you, but I don't really think too much in terms of secant, so I'll do the reciprocal of cos squared. And cos of pi over 3 is 1/2. So I get 4. Tangent line, you should be racing me. On Desmos, y equals tangent of x. I had the point pi over 3 square root of 3. And my equation was y equals 4x plus 3 square roots of 3 minus 4 pi all divided by 3. Anybody get it? Nobody got it? You got it? Got it? So now we can do the derivatives of all our trig functions, right? In fact, let's add them to our shortcut list. Y equals sine of x gives me y prime is cos of x. Y equals cos of x gives me y prime is negative sine of x. Y equals tangent of x, now I have memorized as y prime is secant squared of x. Using the quotient rule again, I can get the derivative of cotangent, and I get y prime is negative cosecant squared of x. I just have it memorized, right? You should derive it and then make sure you put it on your list. If y equals secant of x, y prime is secant x tan x. And if y equals cosecant of x, y prime is negative cosecant x cotan of x. So cosecant of x, negative cosecant cotangent. Oh yeah, it's not, it doesn't look that good. I know, I agree. Michael, what'd you say? Yeah. So I think I cut it off at section 3.2 for homework. Let me just double check. Let me wait and make sure you got this. So let me just check this homework list here. Yeah, up to 3.2, so that's fine. So it's a lot of work for Monday, but get on it. I'm not going to add, even though I'm going to teach more tomorrow, I'm not going to add more to this list. It's too much already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 problems. And please make sure I'm adding other instructions here besides the book. So read the book instructions and then include my answers to my instructions. Nice. Let's take a quiz.